Okay. Let me check on you guys on Zoom one more time. Okay, guys, you guys look good. Okay. And let's work here. All right. Welcome, scholars. So we are in the home stretch, right? Let me see. So we're only going to meet 3 more times. We have today, and then next Monday and Wednesday. This upcoming Wednesday, we're going to be off. The school closes at noon, so we're just not going to meet. So enjoy your holiday break. May I encourage you to maximize the time with your loved ones and the people that you care about. If you care about somebody, it's a good idea to tell them that you love them. No moment is guaranteed. At the stage I am in my life, man, people are just disappearing like flies. Like 1 minute, we're arguing or laughing, playing, just in each other's presence. Next thing you know, they're gone in a blink of an eye, like a ghost the whole time. It's so surreal. So take this holiday season to just try to be kind, especially to your loved ones, but to as many people as you can. So then after the holiday break, we come back, we meet on that Monday and that Wednesday. So Wednesday, November 30th is the last official day. Since we're going to meet 3 more times, my thought process was, okay, we can take this time to review our exams. Since we have 3 exams, then, like today we'll go through as much of exam 1 together as we can. And so what I've been doing, since I have 4 sections of College Algebra 1, I try to do different questions with each group. So my 9 a.m. class, we did 4 questions. So we did the first 4. My 1 p.m. class, my 2 p.m. class, we did 2 questions, which was like 6 to 7. My 3 p.m., we got through a lot of questions. We got through questions 16. So 7 to 16, something like that. We got through a whole bunch of questions. So then with you all, I'd like to start on question 17, right? And if we get back to the beginning, then we'll just go from there. So again, last day of class. So last time I'm going to take attendance is going to be next Wednesday, November 30th. That Thursday and Friday is the reading period where you shouldn't be meeting with any of your classes. It's a time for you to get your final projects and get things in order, prepare for your finals and things of that nature. I think I scheduled for your final exam to become available that Sunday, December 4th at 11:11 a.m. and it's due that Friday, December 9th at 11:59 p.m. All right. The goal is when you submit your final exam, you're done with my class. All right. You don't want lingering assignments. You're trying to submit things after the final. So I say that to say you want to take time now to go ahead and get all of your assignments to Pearson, as many of them as you can in order. If you're going back and completing old assignments to improve your overall grade, may I encourage you to prioritize your old exams, because that's where you're going to get the most bang for your bucks, because they account for nearly 80% of your overall grade. And then the last thing you want to prioritize are the old homework, because there's going to be a whole bunch of work for little points, right? You're not really going to see your grade move. It's going to be a whole bunch of work, and you're not going to see the results. And again, the goal is when you submit your final, you're done. That's the last thing that you want to be working on, okay? Again, that Friday, December 9th is the hard deadline. So not only is your final exam due, everything on Pearson is going to lock out. So I'm going to be waiting for that Saturday, and then I will go on and pull people's grades and calculate final grades. During the week of finals, so I'm not taking attendance during the week of finals, but more than likely, I'll be on the Zoom call that Monday and Wednesday during class. I'll probably be on there all day. More than likely, I'll just be gaming or something, just hanging out so that you guys can reach me if you have any like last minute questions or anything like that. Okay, I can't think of anything else. I think that's all of the pertinent information. So let's take some time and get through as many questions from exam 1 that we can together. Let me check on you guys in Zoom. Okay. All right. So we're going to start with question 17. And so again, if you want to see like a presentation for questions 1 through 16, I would encourage you to watch my recordings from earlier today. So, I went through different sections with different classes. You can watch my 9 a.m., my 2 p.m., my 3 p.m., or this one, right? All four of those sections are covering exam one. Okay. So then here we're asked to answer the following questions about this function. Okay. Is the point -1, 2 on the graph of f, right? So they're saying basically when x is -1 is the corresponding y, 2. So if we plug in -1, we get 3 plus 1 is 4. 4 minus 2 is indeed 2. So is that a point on the graph? We're going to say yes. Okay. If x is 2, what's the corresponding y? So when x is 2, here, and instead of doing it like that, I kind of want to do, no, this one. Kind of want to do the following. I guess I closed it. I'm going to go here. Looking good. Let's reload and refresh. So I'm going to go to my y equals, and I'm going to type this in. We got 3x squared minus x minus 2. Okay. I'm going to call in that function that I just typed in. So again, when x is -1, the corresponding y should be 2. Okay. Let me see. We got when x is 2, that's 4 times 3 is 12. Minus 2 is 10. Minus 2 is 8. So when x is 2, the corresponding y should be 8. Sorry, 2. For some reason, I don't want to type 2 today. We get our 8. Okay. The corresponding y, we can get rid of this. Okay. Using this information, please list the point on the graph. So then the ordered pair is going to be 2, 8. Okay. So when our y is -2, what's the corresponding x? Let me see. Let's see if I can look at the graph. So if I go to the graph, I think, let me see if I hit calculate. Let me just look at the graph, right? So if y is -2, it looks like x is 0, right? So I just looked at the graph to get a hint. We could have solved. So notice that when x is 0, y is indeed -2. Yeah. So here we're going to put x equals 0. If you need me to like work through that algebra to show how to arrive to that, aside from looking at the graph, just request it and I'll show it. So then 0, -2 is basically the y-intercept. Okay. What's the domain? Okay. So if this is our graph, it looks like we have a U-shaped graph, a parabola that opens upward, that's been shifted down by 2. So the domain is all rails, the very left to the very right. The x-intercept, so we had to set y to 0 and solve. All right, I think we're gonna have to take some notes. I was trying to avoid writing. Let me see, actually, let me look at this. It looks like it's 1. It might be plus or minus 1. Let me try plus or minus 1 before I solve. So if I plug in 1, 3, I don't know. Okay. So when I plug in 1, it's going to be 3 minus 1 is 2. 2 minus 2 is 0, right? And then when I plug in -1, let's see what happens. I don't think -1 works. 3 plus 1 is 4, right? So -1 doesn't work. We could use the quadratic function, but I think I'm just going to factor it. I'm just avoiding writing. I'm gonna do one other thing. I'm just being lazy. So I'm going to go to calculate the zero. So left bound, I'm going to click here, and then the right bound, I'm gonna go right of the zero, and then I'm gonna take a guess as close to the zero as possible. So this says a negative 2/3, right? Okay, so that'll work for me. I think it's a 1 and a negative 2/3. Just avoiding factoring and all of that. We can factor it. We got a negative 2/3. Okay, and let's just check to make sure that those work. So if I call on the function, so first we got a negative 2/3, should get 0, and then we also got 1. We should get 0, okay? Again, if you need me to factor to show how to solve for those, I can. Okay, I think we got the last two. These. Okay. The y-intercept, if you set x is 0, you get negative 2. Come on. Negative 2. Okay, I think that was it there. Use a graph to find the indicated value. When x is 4, the corresponding y is negative 1. Negative 1. Okay, I'm just going to go with that. That's just reading the graph. All right, so this one says student stuff envelopes for extra money. Their initial cost to obtain the information for the job was $720. Each envelope costs 2 cents, and they get paid 8 cents per envelope stuffed. Let X represent the number of envelopes stuffed. Express the cost C as a function of X. Express the revenue as a function of X. Determine analytically the value of X for which the revenue equals the cost. Okay. So it costs them 2 cents per envelope plus $7.20, right? So the cost is 0.02x plus $7.20. Okay. The money generated is going to be 8 cents per envelope. So we're going to say 0.08x. Okay. So if we set the revenue equal to the cost and solve, you get 0.06x equals 720. Hey Siri, what's 720 divided by 0.06?
720 divided by 0.06 is 12,000.
Wow, seriously? They got to do 12. They got to stuff 12,000 envelopes before they break even. Let me see. If you subtract 0.06, divide, yeah, that's what we get. Okay. So then they don't turn a profit until they stuff anything past 12,000 is a profit. Man, that's interesting. I guess I'm done with this because you guys are all here, so I can shut that down. Says the sum of two numbers is 64. Okay, express the product of the numbers p as a function of one of the numbers x. Okay. So we know that x plus y equals 64. So then, like, say we solve for y, we're going to get y equals 64 minus x. So then if we want the product is going to be x times, I think it was 64 minus x. And if we were to distribute, it's like this. We're going to have a square there. Get rid of that. Okay, I think this is it. Okay, I don't really want to submit the test. I want to kind of go to question number 1. Let's see, did it save that? Okay, it looks like it saved it. I guess we can work backwards. Trying to think if I want to go to 1 or work backwards. Let's just work backwards. I guess that'll be fine. Okay, let's keep going. Let's see. So the domain here. All right. So in general, for a rational function, the domain is all reals except any x that makes the denominator 0. So here, plus or minus 6 makes the denominator 0. So we want to capture everything except plus or minus 6, right? So the far left is going to be negative infinity up to negative 6 cup. Then we want to go from negative 6 to positive 6. And then we want to go from 6 to infinity. So when if we want to capture everything except plus or minus 6, this is how we do it. Okay. So we're asked to evaluate for these different values, okay? So when we let x be 0, on the bottom, we're going to have 1. On top, we're going to have 0. So 0 divided by some number that's okay, that's going to be equal to 0. But some number k divided by 0, that's a KO. You want to knock that out. So that's going to be undefined, right? So in this case, we're going to have 0 over some number, which is okay. So that's going to be equal to 0. Can I hit tab? It's fine. When x is negative 1, we get a 0 in the denominator. That's not okay. That's a KO, right? So that one is it does not exist, all right? Because we get a 0 in the denominator. Does not exist. When we plug in 3, we get 3 on top. 1 minus 9 is negative 8. So that's a square root of a negative. Square root of a negative is not a real number. Okay. 2/3. Using radicals. So then 2/3 squared becomes 4 over 9. So 9 over 9 minus 4 over 9 is 5 over 9. So then it becomes the square root of 5 over 3. So 2 over the square root of 5. I'm just going to put 2 over the square root of 5. Okay. I think that's it for that one. Okay. So if we want to determine if this defines y as a function of x, if we solve for y, you would have 1 minus x squared. When you go to take that square root, you're going to get plus or minus. So that means that you can find one x value that corresponds to 2 different y values. So that means that this is not a function, right? I think this is the equation of a circle. It's going to fail the vertical line test, so it's not a function. Okay. So the domain is going to be our set of inputs. Let's see, it's going to be -2, comma, -1, 0, 1, 2, and 3. Okay. And then our range, our set of outputs, go like this, like this. We got 2, comma, -1, comma, -2. We already did 2, 3. We already did -1, right? We don't type each answer only once. So if it fails, if we were to plot these points and it fails the vertical line test, in other words, if you have one x that corresponds to more than one y, or in this form, if we have repeating x's, then it's not a function, right? Just like in life, we're repeating our x's, as they can be a bit dysfunctional, right? So here, if we have repeating x's, we don't have any repeating x's, so then it is a function. Okay, I think that's everything there. So these questions are changing. That's fine though, because like I know I did some of these with my earlier students, and they just kind of jump around. All right, so it says the relation between Celsius and Fahrenheit of measurement is linear. Find a linear equation relating Celsius and Fahrenheit if 0 degrees corresponds to 32 and 35 corresponds to 95. Use the equation to find Celsius measured at 54. Cool. I want to do this one from scratch. This one's fun because it's like, it just is. It's no real explanation or reason why. Because I like it because it's like it's applicable, Let me copy and delete. Let's hop here. Let's paste the image, allow the paste. All right. Did you all see Wakanda Forever? So I kind of want to talk about it a little bit, but if you guys haven't seen it, I'll let it go. I'm not going to spoil it for you to watch it. Let's see. It says, okay, so it's linear. Okay, so that means we're going to be working with, I'm going to use y equals mx plus b. Okay, we have two ordered pairs. So let's see. So we're going to be given Fahrenheit. So let's relate it where we have degrees Celsius is going to be equal to some slope times degrees Fahrenheit plus some b. Right? We're gonna do it like this. Okay. So now we were given two pieces of information. It says that when Fahrenheit, so 32 degrees Fahrenheit corresponds to 0 degrees Celsius. And we're also given that 95, right? 95 degrees Fahrenheit corresponds to 35 degrees Celsius. Okay. Just as I usually use the boiling point because Fahrenheit boils at 212 degrees Fahrenheit. That corresponds to 100 degrees Celsius. So we're going to see if it fits, if it all fits. I usually use the freezing point of water and the boiling point of water to do this, okay? So let's plug this information in. When Celsius, I was kind of hoping it's going to be easier than that, but that's okay. So let's see. We can find the slope. Let's find the slope between the two. So our slope formula. Slope is what? The change in y over the change in x, or y in this case. So it's going to be our first degree Celsius, or here, let's do it like this. Our second degree minus our first degree over our second degree minus our first degree, right? So, okay. So normally I go x1, y1, x2, y2. So we can call this F1, C1, and then F2 and C2. All right, okay. So then when we go to calculate the slope, we should do 35 minus 0 over 95 minus 32. Okay, if that were 40, that'd be 52 plus 8, 52. Something's not right there. If that were 40, that would be 55. 55 plus 8, 63. I think it's supposed to be Here, let's do this right here. This one. By 63 as a fraction. Okay, 5/9 is good. Okay. All right. So then we get 5/9, and I'm going to choose the first point that just like is easier to work with. So then times 32 degrees Fahrenheit. We don't know B yet. When Fahrenheit is 0, no. Yeah, let's keep going. And then, so when Fahrenheit is 32, Celsius is 0. Okay. So then ultimately we get B equals, it's going to be what? -5/9 times 32. I think this is fine the way I have it written. Let's do math as a fraction. We get a -1/9. Okay. I think we usually have it the other way, but this is fine. Okay. So then our claim is that the degrees Celsius is going to be 5/9 times the degrees Fahrenheit minus 160/9. That's usually not the way I have it written. I think I gotta, if I switch the degrees Celsius and degrees Fahrenheit, if we switch it, it should be, I think it goes degrees Fahrenheit equals 9/5 times degrees Celsius plus 32, but something might be off. Because 0 degrees Celsius is what, 32 degrees Fahrenheit. Let me see if this works. I just want to check because that's what I was kind of anticipating. But what we calculate, let me highlight it. So what we calculated, we got this, right? I know that the 0 degrees works. So like when we put in 0, we get our 32. Let's see if it works for the 95. Right? So then if we did 9/5 times what, 35? Plus 32, do we get 95? We do, okay. And then let's check the 100, right? So then if we change the 35 to 100, we should get 212. Cool, okay. So we can at least be confident in the other one that we have. Yeah, let's go with it, okay. So now let's hop back. To this one, it's Celsius. Okay. So if we factor out here, let's take it a step further. If we factor out 5/9, we'll get degrees Fahrenheit minus. Hey Siri, what's 160 divided by 5?
160 divided by 5 is 32.
Okay. All right. That's interesting. Yeah. Cool. So 5/9 times degrees Fahrenheit minus 32. So it looks like we get A. All right. So 54 degrees Fahrenheit as Celsius Let's do 5/9, 54 minus 32. Okay. So 1 decimal place, so 12.2 degrees Celsius. Oh, okay. Let me check on you guys in Zoom. Let's keep going. Stop. Okay. All right. Let's keep going. So let's do the next one. So it says that the equations of two lines are given. Determine if the lines are parallel, perpendicular, or neither. Okay. So whenever we're discussing lines that are either parallel, perpendicular, or neither, all it's saying is compare and contrast the slopes of the lines, right? So we're comparing the slope of the first line to the slope of the second. So let me get a copy of this guy. Come on. Okay, I'm gonna hit copy and delete. It's kind of cool. Like as I'm working with you guys, I have it on my phone. I'm watching the stream just so I know that it's healthy and I get a sense of at least what people can see. I'm not listening to it, but I can at least confirm that the image is being pushed. Okay. So we have the equations of two lines. Determine if the lines are parallel. So basically, we need to find the slope of each line. Let's do the first one. Let's do this dark green. So we do equation 1 in dark green. We're going to solve for y. So we have this negative 6x minus 3y equals -1. If I add my 3y and add 1, we get 3y equals -6x plus 1. Divide both sides by 3. -2x plus a third. So then here, our slope is -2. And let's do this other one in dark blue, equation 2. So we got this 2x minus 4y equals 3. If I solve for y, add and subtract, 4y equals 2x minus 3. Divide both sides by 4, y equals 1/2 x minus 3 by 4. Okay, so then our slope here is going to be 1/2. So notice that when we say slope 1 times slope 2, we get -1. That's the definition of two lines being perpendicular. So when two lines are perpendicular, the product of the slopes is going to equal -1. Okay. So then these lines are perpendicular lines. So we're going to go perpendicular. Now, obviously, you could guess. You got a 1 in 3 chances of guessing correct, but chance favors the prepared mind, right? So the better prepared you are, you drastically boost the odds of success in your favor. Okay. So hopefully the odds will forever be with you. Anybody get that movie reference? May the odds forever be in your favor. I had a professor say that to us as we went into an exam. Man, I was like dead. I was like, ugh, it was such a pain. Anywho, I guess it's another one, right? So we have the equations of two lines are given. Determine if the lines are parallel, perpendicular, or neither. Okay. They're both horizontal lines. The first one is y equals -8. The second one is y equals what? 2. So you just have two horizontal lines, so then they're parallel to each other. Use the given conditions to find an equation that's, what's the time? We got time for maybe one or two more. Use the given conditions to find the equation in slope-intercept form of the line. If the line is vertical, write it in the form of x equals h. Okay. Slope-intercept is y equals mx plus b. Okay, so we need to find the slope between these guys. I'm gonna just take some notes here. Our slope is gonna be, so the change in y, so let me see. X-intercept is -6. A positive 12, so we should have a positive slope. So it looks like it's 12 divided by 6, which is 2. Looks like the slope is 2. Okay. Write an equation. So we're going to have y equals, our slope is 2x, and our y-intercept is 12. Okay, let's make sure this works, all right? All we did was find the slope, and they gave us the y-intercept, so we just put those two pieces of information together. Okay, let's make sure that this works. So when x is -6, the corresponding y should be 0. 2 times -6 is -12, plus 12 is indeed 0. When x is 0, y is 12, and that checks out as well, right? So this should be good to go. Let's do at least one more. Find the equation of the line with a given slope. So the slope is 0, and the y-intercept is 2, so this is going to be y equals 2. When it has a 0 slope, it's a flat horizontal line through the given y value, so it's just going to be y equals 2. Find the slope of the line passing through the pair of points, or state that the slope is undefined. Okay. Then indicate whether the line through the point rises, falls. Okay, so basically it's asking us to find the slope. Okay, so it's a change in y over change in x. Xy, x1, y1, x2, y2. So then 3 minus 1, I'm gonna just do it here. I'm gonna say 3 minus 1 over 5 plus 2, because it's really 5 minus -2 becomes 5 plus 2. And then I'm gonna just keep working over to the side here. I'm gonna hit equals. That's gonna be 2 over 7. So it's a positive 2 over 7. I'm gonna get rid of this stuff. So it rises, since the slope is positive, it rises from the left to the right. Okay, let me see what the next one looks like. It depends. Okay, let's do this one. Find the equation for the graph of a point that moves such that this is the same distance from this point and the y-axis. Let me think about this one. Equation of the graph of the path of a point that moves such that that point is the same distance from this and the y-axis. Oh, okay. So we're at the point 2, 0, which is the x-intercept. Same distance. So the distance is growing there. What's the general shape? Is it like a V? X equals? What is it, like x equals 4? From the point 2, 0 and the y-axis. The equation, type of expression using y as the variable, okay. So like for instance, if you start on the x-axis, it seems like you would start at x equals 4, right? So then when, man, all right, that one I don't know immediately. I would have to like think about it, and I wasn't really trying to think right now. Let me see. In my mind, I'm getting a V. I'm thinking it's like a piecewise function. Let me think about it for just a moment. Let me think. I want to just. I'm thinking like a piecewise, but I can't get the basic shape. Because because it's like if I'm on the x-axis, it makes sense to start at 4 because, oh, wait a minute. No, I guess you would be halfway between those. So it would be something like x equals 1, right? Halfway. So you're 1 away from that point, and you're also 1 away from the x-axis. I mean, the y-axis. So then, because if you just did a vertical line going directly up, you'll always be 1 away from the y-axis, but then your distance away from that point is going to be increasing. So in order for the distance away from the y-axis to increase, I'm thinking it has to be like a diagonal line, like a V almost, a sideways like absolute value function. Is it like 1 to 1? Okay, just for the sake of time, I'm going to like not answer that one. I'm going to go ahead and submit the test just because we're out of time. But I do kind of want to see that one. I'm going to submit. That's fine. Okay. So we did get 1 wrong. Let's look at 17. Let's see what happened here. Oh, we didn't list it as order pairs. That's fine. We missed one. 0, 2. We just missed the other one. I thought that we had calculated that. Okay, we should have calculated, right? I think what number is that? Like wait a minute. Yeah, I think we should have written it out. I think we just looked at the graph, right? We didn't confirm. We didn't like calculate. We probably should have calculated, but that's fine. Let's see. And I wanted to see this one. That one was interesting. Oh, it's a parabola. Okay. Okay, well, we were close. We were thinking of V, right? It's basically a sideways parabola. That was the basic shape. Once I had the basic shape, then we could have got it from there. But that's okay. Okay. Oh, it's 4:44. All right. So we're going to go ahead and end the session there. Any questions before we go our separate ways? Give me just a moment. Okay. So while you think of questions, I'm going to share a copy. Let me see. I just want to see that one that we got wrong. It's okay. Because I probably didn't even write anything down. Let me send this to Box. All right. So when this bar finishes loading, you'll receive a copy of everything that you saw me writing. If there are any burning questions, we're going to end the session here. Happy holidays, safe travels. Hope you all can maximize your time with your loved ones, and be sure to tell somebody that you care about, that you love them, that you care about them. And from one beautiful mind to another, happy holidays, guys. Take care. Peace.
Hello.
Yes.
Hi. How are you?
Well, yourself?
I'm doing okay. I'm running to the airport now, and I really wanted to talk to you because I had fallen behind in math, but I know you said that like the stuff is due on the 8th, and I was in class last week, and I know you said to prioritize the exams, so that's what I'm doing.
Yeah, that's fine.
Yes. So, and the final will be.
So it'll become available. Let me see. Let me pull up my calendar again. I think it's the 4th. It's like a Sunday. That Sunday before the week of finals at 11 p.m. And then everything locks out that Friday night, December 9th at 11:59 p.m. Got it.
And will we have class? Wednesday. Will we have class?
So we're going to meet on. We're not meeting this Wednesday. I think the school closes at noon, so it's a holiday. We're not going to meet. Next week we meet on Monday and Wednesday. That Wednesday next week is going to be the last time that I'm going to take attendance. during the week of finals, more than likely I'll be on the Zoom call. You can just log in if you just have questions, but I'm not taking attendance during the final. I'm just making myself available if you guys need support or have questions about anything.
Got it. Thank you so much. You have a great holiday.
You as well. Happy holidays. Take care, guys.
Bye-bye.
Mhm.